Hello viewers. So in this video, we'll be looking at trigonometric functions of triangle. So here we'll see how to find the trigonometric angles of any kind of angle, not necessarily acute angles. But let's start with this one. If you have a theta in standard position, and you have a point P of xy to be a point on the terminal. Now, this is what we mean. This is theta in standard position because it starts from the initial side is the positive x-axis, and the vertex here is the origin. So if this is a point Pxy, so it means that this distance is x, and this distance is going to be y. And we can find sine theta. Sine theta is just opposite over hypotenuse, which is y over what? Which is y over x, right? Going to be y over x. And also what we can also see is that cosec is going to be the reciprocal, which is r over y. And here we have cosine theta is also x over r. So sec will be r over x. And tan theta is opposite over adjacent, which is y over x. And the reciprocal cotan will be x over y. So this is how to find these things, these trigonometric ratios. Once we know the points, and it means once you know the point, we'll know which quadrants will belong to. So like this one here, we see that in the first quadrant, all the trigonometric ratios are positive. In the second quadrant, only sine is positive. So this is only sine. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So we can recall this one by using all students take calculus. So let's just delve into the solving questions. It said if a point, so you have a point here. And what is this point? This is x and this is y. So you can see that here x is negative and y is positive. So this looks like a point in the second quadrant. So we're going to have a point in the second quadrant, which will be our terminal. So this is our point P. You can call it P, but it is minus half root 3 over 2. So what that means is that here, the distance here is going to be half, but we know it's from the negative x-axis, and y is going to be root 3 over 2. So this point here is actually root 3 over 2. And now you can have your theta in standard notation. So here, what do we want to find? We want to find tan theta, right? So, but what is tan? Remember, we say tan theta is going to be y over x. In this case, what is y? Y is this distance here, and this is x. So y is going to be root 3 over 2 divided by x, which is minus half. So therefore, tan theta is just minus root 3. Because we will get we'll get root 3 over 2 times minus 2 over 1. So tan theta is just minus root of 3. Okay. All right, so let's move to the second one. The second one here, it says that the terminal side. Where is the terminal side? The terminal side of angle theta in standard position is defined by this line. You have a line x minus 2y equals to 0, right? So, but we're also told that x is greater than 0. So we have to use this information. So this means that x is 2y, And we can say that y is equals to x over 2, right? Now, since you have a condition that x is greater than 0, so you can take x to be any positive number, but here let's use 2 so that y can be also an integer. If x is 2, this means that y will be 2 over 2, which is 1. So it means we will have a point 2 and 1. This will be the point we will deal with. And if you look at this point is going to be on the first quadrant because x is positive and y is positive. So let's say this is our point 2 and 1 is on the terminal, meaning that what if I have a right angle here, the x value from here to here is 2, the y value is what is 1. So with this we can easily find what the hypotenuse will be. The hypotenuse will just be the square of 4 plus 1, right? So square root, so it will be square root of 5. And don't forget, we will have our theta here. Okay. So now what to do? We just need to find the ratio. What are we looking for? We're looking for sec theta. So what is sec theta? We just need to recall that sec theta is the reciprocal of what? Of cosine theta. So it means sec theta here. What is cosine theta is what? Is x over r. So sec is going to be r over what? R over x, which is hypotenuse now over what? Hypotenuse over opposite, right? Because sec, you know, we have, this is what we have, so catoa, right? So cosine is what? Is adjacent hypotenuse. So sec will be hypotenuse adjacent. So here, and what is our hypotenuse? R. Remember, this would be R, this would be Y, and this would be X. So this R is always positive. So here we have root 5 over X. What is X? X is 2. And we're done. So sec theta is just root 5 over 2. Okay. Now, number 3. For the third question is similar to what we just did. Here you have a line. Now, what is that line? That line is x plus 2y equals to 0. And also here we can say x is what? Minus 2y, right? And y is going to be, what is y? It's just going to be minus x over 2. You can have this one. But here also we have this condition that x is greater than 0. So we can take x equals to what? 2, because it's positive. And if x is equals to 2, it implies that y will be minus 2 over 2, which is minus 1. So now you're dealing with the point 2 and minus 1. Okay, so 2 and minus 1 is a point in which quadrant? X is positive, y is negative. It's going to be a point in the 4th quadrant, somewhere here. So this point is that point, 2 and minus 1. Okay, so here you have your right angle. The x distance is going to be 2, and here it's 1. So in the same way, we can use Pythagoras theorem, just like we did earlier. Use Pythagoras theorem. Here will be root of what? Root of 5, and here we have the theta, right? So now we're interested in sine theta minus cosine theta. So first of all, let's get what is sine theta. Sine theta is going to be what? Remember, sine is opposite, which is y over what? over r. And what is y here? This is 1 here, but we know it's going to be minus 1, right? It's a minus because of it's in the negative side. So this is going to be minus 1 over r is still root of 5. So it means that sine theta is equals to minus 1 over root 5. And this makes sense because we know that in the fourth quadrant, sine should be what? Only negative. It cannot be positive. All right. So now let's go for cosine theta. For cosine theta, what do we have? Cosine is x over what? Over r. And what is that x? X is what? It's adjacent, so it's going to be 2 over what? Root of 5. So you can see the cosine is positive, which makes sense because we are in the what? In the fourth quadrant, is as expected. So now if you want to find sine theta minus cosine, let's just go up. Okay. So if you go up there, we can just finish this here. Sine theta is minus 1 over root of 5. Then minus cos theta, which is 2 root 5. And this will give us minus 3 over root 5, right? And if you rationalize this one by root 5 over root 5, we will get what? We'll get minus 3 root 5 over 5. All right. Now example number 4. So for example number 4, what do we look at here? We see that what? Cotan theta is this. So this is telling you that cotan is positive, but we know cotan can only be positive where tan is positive. And tan is positive in which quadrant? In the third and the first, right? So we have first here and third. And sec theta is less than 0. What do I mean by sec less than 0 is what? Where sec is less than 0, wherever cosine is less than 0. So cosine is less than 0 in which quadrant? Well, less than 0 means negative. Cosine is less than 0 in the second. And in the what? In the third quadrant. So here we will choose which quadrant? We will choose the quadrant that is common, which is quadrant what? Quadrant number 3, right? Quadrant number 3. So here you can see that the common quadrant is quadrant 3. So it means that we're going to be in quadrant 3. So just go to quadrant 3 and draw your theta. So this is going to be theta. You can call this theta, right angle triangle. But what we have is that what's cotan is what? 2 over root of 5, right? But what is cotan? Cotan has to do with tan. So remember, this means that if tan, theta is y over x, so cotan is going to be x over y. So this simply means that your x is 2 and y is what? Root of 5. So x is 2, so it's going to be this way. But since you are in the negative x-axis, it's actually going to be minus 2. And what? Y is what? Let me draw this properly. y is this distance, which is root of 5. But here also is on the negative axis, so it is this way. Right. So here we can use Pythagoras theorem to get what is the hypotenuse. This is going to be root of what? The square of this, which is 5 plus 4. So this is going to be square root of 9, which is just going to be 3, right? This is by Pythagoras theorem. Okay, so let me draw it there. R is going to be root of x squared plus y squared, which is just x squared is what? 5? No, x is 2. So you have 2 squared plus what? Root of 5 squared. And this is root of 9, which is equals to 3. So r is 3. So now we can find what is sine theta, cosine theta. So we know that sine theta is usually what? Is usually opposite, which is y over r, right? That is sine theta. Okay, so let's get sine theta. So sine theta in this case is going to be what? What is y? Y is minus root 5 over r, which is 3. Remember, this is over y, this is r, and this is x, right? Now, if you want to find cosine theta is x over r, and that is going to be minus 2 over what? Over 3. So now you see that we are in the third quadrant. So cosine and also sine, they are both negative, right? So it means that to find sine theta, cosine theta, you just need to multiply these two, which is minus root 5 over 3, and then minus 2 over 3 as well, right? Yes. So minus minus become positive. So you have 2 root 5 over 9. All right. So similarly here, in this example 5, cosine theta is negative. So cosine can only be negative in the second and in the third quadrant. Okay. Yes. But here you have sine is positive. Sine is positive in the first and in the second. So just like we did earlier, we'll take where it's common, the quadrant that is common, which is quadrant number what? Number 2. So if you take quadrant number 2, what do we have? For quadrant number 2, we have, you just need to go and draw in the second quadrant. So we have in the second quadrant, which is this. Now this is the second quadrant. So we have what? Cosine theta is minus half. So cosine, as you can see, cosine is what? Is adjacent over what? Over hypotenuse. So it means that this is going to be 1. Yes, because remember cosine is what? Is x over r. So this would be our x, which is minus 1. And the r is the 2. Then we can find y. Remember, using we can use Pythagoras theorem. Pythagoras theorem, we have r squared is equals to x squared plus y squared, right? So what is r squared? This is going to be 2 squared is equals to 1 squared plus y squared. So y is going to be the root of what? 2 squared minus 1 squared, which is just going to be root of 3. So it means that this is root of 3 and is in the positive direction. Okay. So now to find cotan, theta plus sec theta. What is cotan? Cotan is the opposite of what's of tan. So this will be x over y. So let me just put it here. So this is going to be x over y plus cosec. Cosec is the reciprocal of sine. Remember, sine is what is y over r. So this is going to be r also over y. Now, what is x over y? X over y is, x here is -1. So we have -1 over y. Y is √3 plus r is 2 over y, which is also √3. So here you just have -1 plus 2 over √3. And this should be 1 over √3, which we can rationalize so that you have √3 all over 3 as the final answer. Okay. All right. So that is the end of this, the first video for this section. If you find it interesting, just kindly share with your friends. And if you are yet to subscribe to my channel, kindly do that. Thank you for watching. If you have any questions, just put it in the comment section. Thank you.